Welcome to Triomeet. In this lecture, we'll be solving exercise questions from units and measurements. So let's start. Question 2.14. Question here is, a book with many printing errors contains 4 different formulas for the displacement y of a particle undergoing a certain periodic motion. So they've given these different equations out here, and they wanted us to check if these formulas are correct. Rule out the wrong formulas on dimensional grounds. Now, how do you solve this problem? So we know that in an equation, the dimensions on the left hand side should be equal to the dimensions on the right hand side. This is how you can determine whether an equation is correct or not. And how do you mention the dimensions? Mass is represented as m, length as L, and time as T. Okay, so the first formula that we have here is, part A of the question is, y equal to a sine 2 pi t by t. Now, y, they've given it as displacement y. Displacement y means it is length. So, LHS here is L. What about the RHS part? A. A is given as the maximum displacement of a particle. This one's dimensional formula is also L. Now, we've got sine of 2 pi t. What is capital T? Time period. Small t is also time period. So all of this, both of them, the dimensional formulas will cancel out each other. So we get sine of 2 pi, which is a dimensionless quantity. So since this is dimensionless, this equation is correct because L and L, the unit is the same. So part A of the question, the first one is correct. What about the second one? The second one we have here is y equal to a sine Vt. We know y is displacement, so the LHS is L. What about A? We should determine whether LHS is equal to RHS. If LHS is equal to RHS, the dimensions are equal, the equation is correct. If it is not equal, the equation is wrong. So A, displacement, so that is L. Now sine of a quantity should be dimensionless. V, what is V? V is the speed of light. So we know speed of light is equal to, the unit is meter per second. Meter is L. Second is time, mentioned as Lt raised to minus 1. So we've got Lt raised to minus 1 into dimension of T is T. So we see this and this cancel each other. We've got sine of L. The quantity here should be dimensionless, but we've got a quantity of sine of dimension L. Hence, this equation is wrong. The LHS does not match the RHS. We are not getting sine of a dimensionless quantity. So, equation B is wrong. Now, to solve the third part. Third part of the question is y equal to a by t sine t by a. Let's see if this equation is correct. LHS should be equal to RHS for this equation to be correct. We know y is displacement, its dimensional quantity is L. A is displacement, so its dimensional quantity is L. Time is represented by T. Sine of T is represented by dimension T by L. Here also we can see that this is not a dimensionless quantity. This is not equal to LHS, is not equal to RHS. So even this equation C is wrong. Now what about D? What is the question of D? D is equal to, the question D is y is equal to a root 2 sine 2 pi by 2 pi t by t plus cos 2 pi t by t. Now let's check whether this is dimensionally correct. Y is displacement represented by L. A is displacement represented by L. The constant root 2 can be avoided. Sine 2 pi dimension t by t. This will cancel out. Plus cos 2 pi dimension t by t. Dimension t. This will also cancel out. So we get dimension L is equal to L, because this sine 2 pi is a dimensionless quantity, cos 2 pi is a dimensionless quantity. So we get LHS is equal to RHS. So from here we found out A and D are both correct equations, whereas B and C are wrong equations. Question 2.15. A famous relation in physics relates moving mass m to the rest mass m0 of a particle in terms of its speed v and the speed of light c. So the quantities mentioned here is m, m0. These are both mass. One is a moving mass, the other is a rest mass. In terms of the speed v and speed of light c, both of these quantities are represented as speed. Now the question is, this relation first arose as a consequence of special relativity due to Albert Einstein. A boy recalls the relation almost correctly but forgets where to put the constant c. He writes m is equal to m0 divided by 1 minus v square whole raised to 1 by 2. The question is where to insert c in this equation. So, what is given to us? This equation. We know from the dimensional analysis that the left-hand side of an equation should be equal to the right-hand side of the equation. That is, the dimension on the left-hand side of the equation should be equal to the dimension on the right-hand side of the equation. Now, how do you solve this? How do you represent dimensional analysis, right? So, in case of mass, we represent it as m. If it is length, it is represented as L. Time is represented as t. What is speed? It is distance per unit time or meter per second. How do you mention meter in dimensional analysis? Length would be L. Second in time raised to minus 1 or L by t. Now let us insert the dimensional analysis in this equation. So we know dimension of m to be mass to be m. We've got the rest mass to be represented as m. What about the below equation? That will be 1 minus v. We found it to be speed. How is speed represented as? Lt raised to minus 1 the whole square, because this is square mentioned here. This whole raised to 1 by 2. 1 is a dimensionless quantity. Like the numbers are dimensionless quantities. We need LHS. We know LHS is m. RHS also has to be only m. So we need to somehow cancel this Lt raised to minus 1. So in that place, if I write it as 1 minus Lt raised to minus 1 the whole square divided by Lt minus raised to minus 1 the whole square raised to 1 by 2. We see that the equation is correct because this and this will cancel, and then we'll get a LHS to be equal to RHS. Right? So how do you write this as? This will be m, in terms of the actual unit it will be m is equal to m0 divided by 1 minus v square divided by we needed to know where to insert c. C is also speed of light, that is Lt raised to minus 1. We can write it as c, but if you got a square here, write square raised to 1 by 2. So our final equation is m is equal to m naught divided by 1 minus v square by c square, the whole raised to 1 by 2. So this is the famous relation. And the end of this question.